Hey, it's been a bit, just a little bit since my last devlog. Um, the reason being is I, in fact, got busy with Moonjam, the Twitch streamer Moon's game jam, but I'm back. So, welcome to the third devlog of Untitled Gravity Game. In this devlog, I'm going to go over draw call reductions, instant static meshes, and the mistakes I made along the way. Which I know it seems a bit early for optimizations, but as shown, there's video stuttering when recording the main menu. And this was also present in the first devlog, however, I was able to cover it up to some extent by cutting up the footage. But with how simple the game and models are, it seems a bit strange I'm getting any stuttering. And I don't think the stuttering stems from the triangle count of the pickup model since it's about 2,000 triangles per model, and even at 900 spawned, we are looking at a bit shy of 2 million, which most computers are able to handle 5 to 6 million easily. The first thing I thought could be the problem was material draw calls, as I was spawning a dynamic material instance for each pickup item instead of spawning one dynamic material instance per color and assigning the material to multiple items. So that was about 900 dynamic material instances, which resulted in over 1800 draw calls. Yeah, not great, but this system was made during the prototyping stage. However, before discussing the fix to the material draw calls, there's another mistake I made. So I want to quickly touch on that as both mistakes go hand in hand. So when spawning the pickup items, along with creating the dynamic material instance in the actor, I also gave each actor an instance static mesh component instead of a regular mesh component. So each pickup item had an instance static mesh with one spawn location for the mesh. However, the correct way to use instance static meshes is to pass multiple locations at which the mesh exists. So, for example, one instance static mesh would handle all the locations of the white pickup items, another would handle all of the red, and so on. Which brings us to the solution. Instead of the old system where the pickup spawner would find each spawn location, then spawn pickup item actors at those locations, where each actor would have its own instance static mesh and dynamic material instance, the new system is going to be spawning multiple clusters, one for each color. So now instead of 900 instance static meshes and dynamic materials, there will be 4 in total. And with that, we can remove the code corresponding to both features out of the pickup item actor and leave only the on-collision actor destruction and the logic to increase the player's points. However, as I write this section of the devlog, I thought of a possibly better system that I'm not sure could actually work, but much like how the instance static meshes take multiple locations to spawn their mesh, why not do the same thing with collisions, where they would be stored in an array? That way, if the 20th collider in the array gets collided with, then it's removed along with the 20th mesh instance. But in all my time learning game development, I've never seen anyone demonstrate that before. Usually it's placing the collision and the mesh into its own actor, like previously shown. So again, I'm not sure if it's possible. However, the optimist in me wants to believe that Unreal is already doing that to some extent under the hood. And sorry for my ranting, but if this is possible, then it would solve an edge case where I couldn't delete any of the mesh instances, as I was passing the item actor containing the collider the mesh instances index. So when deleting other item actors, the current had a chance of no longer pointing to the correct index. For example, when deleting index 5, index 6 would shift down to being index 5, but the item actor will still reference index 6, unless I were to tell every other item actor with indices above 5 to lower their values by 1. So the hacky solution was to move the mesh instance really far away to take advantage of the lowest quality LOD and to only delete the pickup item actor. That way the other item actors will reference the correct indices. And as I began to rewrite this section of the script to reiterate my uncertainty to making index-based collision detection, I thought, why don't I just spend an hour or two prototyping to see if it's possible? And after 20-30 minutes, I believe I have pretty good proof of concept. It mainly works by using delegates to bind a collision event to each index, which reminds me a lot of how lambda functions work, but I'm not sure if that's really what delegates are. Also, it's able to track which index is being removed, so now I should be able to remove the correct instance location, meaning instead of the super hacky moving the instance really far away, I can just delete it along with the collider. However, with these changes, the draw calls have been reduced from a max of 1400 to 7 with the dynamic material instances and instant static meshes. So I guess it's time to re-record the main menu. And they're still stuttering. Why? A few optimization videos later, and let's try the stat rhi command. Uh, why do I have 5 million triangles drawn? The answer to that is instant static meshes don't use LODs. So regardless of the LODs I generated for the mesh of the pickup item, LOD 0 is the only one being used at all distances. So question, did I just shoot myself in the foot? Did I just spend several hours updating the spawner to then throw it all away, or is there a way I can leverage instant static meshes while obtaining an LOD system? And while writing this, I assume at this point you expect me to say something crazy like, I made 5 different pickup meshes, each with a different imported triangle count, and set up several clusters with a different LOD for each one, then toggle between which one needed to be displayed at varying distances. Well, no. I didn't do such a thing, but I probably got you thinking I did for a second. Uh, no, I use hierarchical instance static meshes, which is just instance static meshes with LOD support. So after replacing the instance static mesh reference in the clusters with a hierarchical instance static mesh, I tested it to make sure everything worked, and as shown, it went from 5 million to 250,000 triangles per frame. So let's test building a shipping version. And cool, no errors. So I guess all that's left is playtesting it, but it seems like it's taking a bit longer than usual to. Oh, well, it wouldn't be an Untitled Gravity game devlog if there wasn't some obscure bug with Unreal Engine now, would it? Luckily, this is fixable by upgrading the engine version, and being most of the project was written in C++, there shouldn't hopefully be much to fix. However, I didn't record the upgrade because I didn't know how long it was going to take, but basically the only things that needed fixing was a broken timeline in one of the blueprints, and to recompile the plugins after deleting their intermediate and binary folders. And remember how I was talking about the new spawner architecture earlier? Well, that was after I switched to the hierarchical instance static meshes, but guess what? After 3 to 4 hours of implementing it into the pickup cluster class, it didn't work. At least it didn't work the way you would think. The remove instance node, when hovered over, talks about how the array order is preserved after deletion. That is in fact a lie. So that means we're back to the index references no longer referencing the correct index, which I spent 30 minutes to figure that out because I was so sure the hover text wasn't lying to me. But at that point, I decided the best course of action was to print out the referenced indices and to try to figure out if there was a pattern to the incorrect index references. And as a matter of fact, there was, but not before an angry Twitter post and taking 30 minutes to calm down because, regardless, we're all humans and we make mistakes, but also Epic hire me. uh, but after calming down, I studied the clip and figured out the pattern was the index to remove was being switched with the last index, then the last index was being deleted. So I decided to make a bug report, then looked into the source code to make sure the assumed pattern was correct. And after determining it was, I coded the collider array's index deletion to work the same way as seen here. And for the bug report, I expect the outcome will be the hover text is changed to what the method actually does, as I agree that switching the index with the last then deleting is faster than deleting and shifting all the indices downward. In the chance that any of you attempt this as well, there's one last problem you may encounter, which I'm hesitant to label as a bug because I don't know much about lighting. But there's a shadow problem with both types of instance static meshes, where my solution was just to turn off the cast shadows option, but maybe one of you have previously experienced this and know of an actual solution. But aside from that, everything else works, and to reiterate, the triangle count was reduced from 5 million to 70,000, and the draw calls went from 1400 to 7 on the main menu. However, still good optimizations overall, which should cover making a mobile port faster in the future, especially since the upgrade to 4.27 was done earlier instead of later. But sadly, none of this still solves the main menu stuttering problem, because it was never an engine problem. It's either my computer is slowly dying or my OBS isn't set up correctly, which I've switched between both types of encoding as I have a 1070, so Invect might have been the problem, but nope, I still have video stuttering regardless. So yeah, however, thank you for watching. I intended this devlog to be the lull between 2 and 4 with, nav mesh generation and pathfinding respectively. But the more I wondered how far I could push the rendering optimizations, the more problems I encountered. So yeah, this video was more involved than I intended it to be, but I learned a lot and I hope you did too.